Hello folks, we are coming to the last part of this video, miscellaneous exercise. It's also the concluding part of our 11th standard textbook exercises. So once we finish this, we are starting with our 12th standard exercises, and once if the 12th standard also finishes, then we can do some videos on concepts of this 11th and 12th together. So let's see how we are able to work it out. So this is our last video, and this is how we are going to conclude our session. So here what they say is, in the problem number 9, it's a part 4 video, and in the problem number 9 they are saying that you have got a choice of numbers 0, 1, 3, 5, 7, and from these 5 numbers you have to form digits which are more than 5000. Now what you have to do is, once you have got numbers greater than 5000, that for the event that the number is divisible by 5, you have to find out the probability. Okay, with two cases, when repetitions are there and when repetitions are not there. So that's the question all about. So let's talk about the sample space. Now, because you are having numbers that is greater than 5000, greater than 5000 is 4-digit numbers, right? So I should read the question once again. If 4-digit numbers, they've told, so 5-digit numbers you don't take. 4-digit numbers greater than 5000 are randomly formed from the digits 0, 1, 3, 5 and 7. What's the probability of forming a number which is divisible by 5 when the digits are repeated and the digits are not repeated? So let us be the sample space. Yeah, let's make ourselves understand. Suppose these are the 4 places. So this place can be occupied by 5 or 7 if it has to be greater than 5000. Now once this is occupied by 5 or 7, then this place can be occupied by any of the remaining, right? Only thing here, because it has to be greater than 5000, we specify that it can be 5 or 7, it can be filled in 2 ways. Remaining can be filled by all the remaining 5 digits, 5 ways. This also can be filled by 5 ways. This also can be filled by 5 ways, because in the sample space we are not looking out for conditions, right? We are taking all possibilities. So for a number which has to be greater than 5000, so many possibilities are there. So n of s will be, this is 2 ways, only 2 things are there, remaining is 5. So 5 5s are 25, 25 into 10, 250. That's a sample space. Now we will look out for the event A, that it is divisible by, let A be the event that the number is divisible by 5. By 5, right? So we will analyze and then we will try to get the number. Suppose we are looking at the 4-digit numbers. So we'll take 2 cases. First case, when we have the digits starting with 5, okay, and next is of course starting by 7. Now if you have to have a number which is, okay, one more thing, this is your first subpart where we are taking what have they asked us in the first subpart? Digits are repeated. Digits are repeated. Yeah, so repetitions are allowed. So this can be, okay, so then I don't think we'll have to take 2 cases. So this place can be filled in 2 ways, by 5 or 7. And then once we have filled this, because it has to be greater than 5000, once we have filled this, if it has to be divisible by 0, divisible by 5, this place can be filled only by 0 or 5, and this can be filled by 5 or 7. I think we'll take it as 2 cases, that's better, otherwise it's all full of confusion. Yeah, we'll take case 1. In case 1, we will take numbers starting with 5. So this can be, it's starting with 5. So here, because repetition is allowed, right? So this can be filled by 0 or 5. So this place is occupied, so this is 2 ways. Then this can be filled in 5 ways, this also can be filled in 5 ways. Why? Because repetition is allowed, right? So 5 ways, 5 ways. So number starts with 5, then units place, number of ways of filling the units place. That is 2, right? Then the remaining 2 digits, number of ways of filling the remaining 2 digits. Is also 5, 5. So therefore total number of ways, or rather n of a, is 5 into 5 into 1 into 2, right? 5 2s are 10, 50. Now case 2, number starts with 7. So this is 7. Same story, this can be filled with 0 or 5. So this can be filled in 5 ways, this can be filled in 5 ways. So I can write similarly. Oh, you cannot say no, n of ways, required number, right? Similarly, number of ways of filling the digits is going to be same way like the one there. I have made a mistake because what did I take? Did I take 5, 5 and 2? 5, 5 and 2. Yeah, here it is also like that, 5, 5 and 2. So that's also 50. Therefore, n of a is 50 plus 50 minus 1. That is 99. You understand why minus 1? Because 5000 should not be included. It's a number greater than 5000. When we are doing this, we are also including 5000, right? So 5000 is included because we say that you should not have 5000. That is why we exclude it. So that same idea you have to do here also, minus 1. Why? Because here also 5000 is included. Understood? So that's how you are getting 249 and 99. Now what we will do? P of a. P of a will be n of a by n of s. N of a by n of s, and that is 99 by 240. Wonder if you can cut it. Yeah, by 3. 333 times and 383 times. That's all, right? So that's a case 1, or maybe subpart 1, where the digits are repeated. Now let's take the subpart 2, where digits are not repeated. Okay, same a holds, like a is the event that the number is divisible by 5. Okay, so but here what will happen, we will have these 4 parts. This can be filled by 5 or 7, 2 ways, right? And because this is divisible by 5, okay, whether we should take 2 cases, no, always I am like trying to put it in one, but maybe it's slightly difficult. Okay, suppose if it starts with 5, then because digits repetition is not allowed, so this has to fill by 0. So once these 2 places are filled, then out of 5, 3 is gone. Then you are left with, out of 5, 2 is gone, so you are left with 3 and remaining 2. Okay, when we don't allow repetitions. Then second one, suppose it starts with 7, then this can be filled by 0 or 5, so 2 ways, right? And then 2 digits are filled, so this is filled in 3 ways and this is filled in 2 ways. So that's how we have to write. So we better write it there itself, so that it's, the number starts with 5. Number starts with 5. So therefore units place can be filled by 0 only. 0 only. Remaining places can be filled in 3, 2 ways. Okay, So required number is 3 into 2, nothing else, because this is also one way, this is also one way. So 6 ways. Now second case, start with 7. So this can be filled by 0 or 5. Then this is 3 ways, 2 ways. So number starts with 7. Units place can be filled with so number of ways is 2. There are 2 ways, 0 or 5. Number of ways of filling the remaining places. Three and 2 like before, because 2 places are already filled. So out of 5, 2 digits are gone. Then you are left with only 3 digits. So first place will be filled in 3 ways, the next place will be filled in 2 ways. So that is 3, 2 you can write. Then we can write number of required number. That is going to be 3 into 2 into 2. Slightly different from the previous case. Previous case we were getting only 3 into 2. Here you have 3 into 2 into 2, because units place we are getting 2 ways, like that. So it is 3 into 2, 6, and 6 into 2, it is 12. So n of a will be 12 plus 6. Unlike the previous case, there is no need to look out for minus 5,000 and all that. Why? Because the case that we are taking, it already takes care, because we will not take a number like 5,000 will not come here, because repetition is not allowed. So that is why that case you don't have to be bothered, and this is how you are getting the probability. Probability of a here is n of a by n of s. That comes to 18 by we have to have our sample space. Here the sample space is going to be different, because repetition is not allowed, isn't it? So let's screw it in over here. Okay, let S be the sample space. So how can we allow the sample space? This can be 5 or 7. And then what happens? So you have to have 5 or 7. So then that is 2 ways. And then this can be, once you have filled this up, then out of 5 you have got only 4 choices: 4, 3, 2. So this is already 2 ways. So n of s will be 2 into 4 into 3 into 2. How much is that? 4 2s are 8, 8 3s are 24, 48. So we have to take that here. How much? 6 3s are 6 8s are 3 by 8. Okay, actually we could have changed event here and called it as B, but because it's the same thing, getting a number above 5,000, I didn't change the event. But sample spaces are changing. Why? Because the kind of choice of your number is different. That is why the sample space is changing. And for both the cases, therefore we take a different sample space and we do our problem. Okay, that's how this works out. So this is exclusively maybe for 1. We can put our 1 from here. So that's about this. Lots of logical thinking and very important, as I said, even from the next year's point of view. That's about it. Then we are coming to the 10th problem, and in the 10th problem they say that there is a number lock in a suitcase which has got 4 wheels and it has got digits from 0 to 9. The lock opens with a sequence of 4 digits with no repeats. There is no repeat. What is the probability that the person gets the right sequence to open the suitcase? We always see those things, and 9 out of 10 cases people forget it and then it's a big mess. So that is another thing. So unless otherwise there are some judicious people who always keep the same password kind thing for everything so that you don't go wrong. And there are some other fussy people who keep different passwords and different locks for different suitcases, and they don't maintain the records properly, or and it gets pirated, and then they are in a mess. So it's that case. You have a suitcase, it has got 4 wheel like thing, and in order to set the key, like for that opening it, you are choosing 4 numbers from the 9 numbers, but 10 numbers 0 to 9, yeah, but you don't allow repeats. Okay, when you don't allow repeats, combinations will not work. Okay, combinations will not work when repeats are not there. So generally when you are given a choice and you have to pick up, generally it is C we do, come on, 20 C3 or like 10 numbers and 4, so 10 C4, come on, we pick it up, and then, but in that picking sometimes you have those repeats and all has to be taken care of. So that is why we will see in how many ways we can form this number. Then after we get across finding in how many ways we can do the number, we will find out the probability of find the probability of a person getting the right sequence, that a person opens a suitcase. That is the next probability, right? So let us be the sample space. Let us be the sample space. So see, if it is a sequence of 4 things, right, we look at the choices. First place we've got 10 choices. Why is this not working? For the first place we have 10 choices. Then having filled this, you are not allowed to repeat, so that digit is gone. You don't have that digit anymore. The choice is not there, right? So out of the 10 choices, now you've got only 9 choices because you have filled one place. So now you've got 9 choices. This place can be filled in 9 ways. Now if you have filled that place also, then 2 digits are gone. You cannot take those 2 digits. So out of the 10 digits, 2 digits are gone. You've got a choice of only 8 digits. So this gets filled by those remaining 8 digits, any 1 digit. So there is 8 choices. Once that place is also filled, 3 digits have gone out of your choice and you've got the remaining 7 digits. Okay, the remaining 7 digits is what the last place is eligible for. You can get it filled by the remaining 7 digits. So this is the probability. I mean, this is a sample space. This is how we figure out the sample space. Then we will check out how we can open the suitcase. So we can write the first place, if you want, it's a small explanation. The first place is filled in 10 ways from the given digits. Having filled this, remaining places are filled in 9, 8, 7 ways. Therefore n of s is 10 into 9 into 8 into 7. Right, let's see how much. 9 8s are 72 into 7. 7 2s are 14, 49 and 150. 5 0 4 0. Right, that is our n of s. Okay, having got that done, we will see what they have asked, how you can open the suitcase. That's what the thing is. Find the probability of a person getting the right sequence to open the suitcase. Let A be the event that the suitcase is opened. Let A be the event that the suitcase is opened. Now, if this person has to open the suitcase, right, how many choices does he have? No choice. That exact number, whatever it is, that number that person has to turn and then only it is going to open. There's no choice that these are 5 numbers, you take any of these 5 numbers and it will open, not like that. Okay, or there are some suitcases, if there are some suitcases where you just get those 5 numbers in any order you do it and the suitcase opens, it's a different thing. You've got different choices, but this is not like that. Suitcases don't open like that. Whatever number you have kept it as a lock, only when you turn that number it will open. Sometimes you can keep 0 0 0, but this is without repeat, so you cannot have that. Sometimes you keep 2 5 0 3, something like that. That particular number has to come, then only that suitcase will open. So there's absolutely no choice for this event to happen. There's just that one, that correct number has to come, then only it will open. So it's the number in which this can happen is only 1, right? There's no choice before us. So number of ways of doing this is just 1, and therefore probability of A is n of A by n of S, and that is 1 by phi 0 for 0. That's a required probability. 1 by phi 0 for 0. So that's the end of our miscellaneous exercise. That is the end of our chapter, and that is also the end of our 11th standard sessions. So it's been wonderful having got it done, and we'll be, without any delay, we'll be meeting for the 12th standard sessions. Thank you.